have here a lovely little circuit that speeds up and slows down a motor. It's got a MOSFET, it's got a Pi Pico, it's got a 4.5 volt source for the motor. Now what I'm doing is I'm raising the voltage and lowering it on the MOSFET's gate. And the gate is what controls when it opens and closes. So as the voltage rises, the motor will go faster. And then as the voltage drops to 0, it will go slower again. So let's switch on our battery box. You can't actually see, but you may be able to hear the motor. And as what we're doing is we're using pulse width modulation on the Pi Pico, and we're increasing the duty cycle and decreasing it. When we increase the duty cycle, we can see that the voltage goes up to a maximum of 3.1 something volts. Our MOSFET is then letting through more or less current as the voltage on its gate changes. And on our oscilloscope, which is now switched off, but we can see how the duty cycle on the oscilloscope rises. And as the duty cycle rises, the motor gets faster and then slow, then faster again. So depending on how long your duty cycle is, that will determine on how much the actual voltage appears on your multimeter. And when I can just feel the motor turning faster and then slower. Here is the actual circuit. I like to draw the circuit out. So here's your Pi Pico, here's the lead for programming. Here was pin 0 and pin 0, 1, 2. But it's the third pin along is the ground. Every third pin on this, every third from the end pin is a ground on the Pi Pico. The ground is attached to the ground of the battery box. The positive of the battery box goes to the motor. There's the flyback diode. Then the other side of the motor goes to the drain. The source goes to the earth, and we have a little 10K resistor between pin 0 and the earth. And then from our output pin, we also have a 180 ohm resistor that goes to the gate of the MOSFET. I've drawn the MOSFET like that because it's easier for me to see which legs of the MOSFET are used rather than using the symbol for a MOSFET. So this is the circuit diagram is like a combination of drawing it a little bit how it looks. And so there, I like to draw out the circuit, then it's easier to just push all the components together. You know where everything's got to go. So here we are using Thonny Raspberry Pi Pico, a motor pulse width modulation. I just copied a program that changes the brightness of an LED. I use pin 0 and the ground pin. Right, so here is our circuit. Here is a pin from the Pi Pico. It goes through a 180 ohm resistor. It goes to the gate of our MOSFET. So here was the pin layout of our MOSFET. We used an IRL520N MOSFET. I think this thing can handle like 10 amps and big voltages, but we're just using 4.5 and it seems to work perfectly with that. So that's using an IRL520N MOSFET that looks more or less like that. I have not really played with MOSFETs before. I know about them, I've seen other people. This was a power MOSFET. It has a maximum voltage of 100 volts. It's got a maximum wattage, I think, of 40 watts, a maximum current of 10 amps. I didn't know all this. I just bought any old MOSFET, in fact, the cheapest one. I looked for a circuit that looked like it uses a MOSFET. and maybe some sort of microcomputer, Pi Pico or Arduino. Put all the components together and was very pleasantly surprised when it worked so well. So I have not used a MOSFET before, the MOSFET with PWM or pulse width modulation. That is so nice to do, and especially with a power MOSFET, I could drive a motor up to 10 amps and 100 volts. So I think the possibilities that one could use a circuit like this are huge. I was very surprised, in fact, that this MOSFET worked on just 4.5 volt battery box. So it all came as a very pleasant surprise when it all works out. You start with hope. You start with, let's just try a MOSFET. And every time you try a circuit, I don't know, it's just so pleasant. It's just a pleasant surprise when your hope expectation is fulfilled. I don't know, the rest of the day when you build a circuit like this, and there is a little bit of a schlep in building a circuit. Let me tell you the schlep that's involved. You first have to, this is what I had to do. You put the MOSFET into a, what do they call it, a breadboard. Then you got to look up which pins they are. Then you got to look on Google for a circuit that involves that sort of type of MOSFET. Then you got to look on Google for a circuit that involves a Pi Pico or perhaps an Arduino Uno, some sort of microcomputer to drive the MOSFET. Then you got to look for code that involves pulse width modulation. I tried ChatGPT, it gave me a reasonable circuit, but it didn't work. So I had to eventually find a program that worked on Thonny, which is the development environment in which this particular Pi Pico is operating on. Works on Python. So, I mean, it's a schlep, and I don't like reading data sheets. I just put this particular MOSFET in, and yeah, it was very pleasantly surprised, as I say, when it all works. So it leaves you smiling for the rest of the day, and that is just what is so pleasant about electronics, that you could put these little individual components together, and then the sum of the parts is more than the whole is greater than the sum of the parts, the gestalt or whatever it's called. So it's just so utterly satisfying when a plan comes together. I don't think people spend enough time alone just thinking, doing nothing. Doing nothing is highly underrated. And don't confuse it for boredom. Sometimes I think one has to force oneself to be bored so that you can be creative and to think and to look for solutions to problems and to think deeply and to focus. So sometimes it's wonderful to just have time and to be alone and to force yourself into that boredom zone almost. I've cleared everything out of the way. There's nothing on my plate. I've got 4 hours to do nothing, and that's sometimes the joy of stealth camping. You're forced, you're alone, you don't take a radio, don't take a book, and you're now going to just sit and think and find solutions to problems and be creative.